Good morning, all of you. In the last period, we have studied about a statistical basis and a classical mechanics, chapter number 2. In that topic, we have studied about the introduction, probability, then principle of priori probability, and also we have to study probability and frequency relation. And now, in today's lecture, we are going to discuss very important article, that is some basic rules of probability theory. Some basic rules of probability theory. In this lecture, we have to discuss a two rules and two problems on the some basic rules of the probability theory. The first one we are going to discuss, that is the additive law of probability, and second one is a multiplication rule, that is for the probability. First of all, we have to say that for any number of mutually exclusive events, we have to consider, that is a probability. First of all, that is number of probabilities, cases, events we have to consider. Let P1, comma, P2, comma, P3, Pn be the number of events. P1, P2, P3, P1 be the number of events for the probability, and that one of them occurs is sum of the probability. Therefore, one of them occurs is the sum of the probability, and that is additive law of probabilities. P is equals to sum of probabilities. That is P is equals to P1 plus P2 plus P3 plus Pn, and finally this can be written as, therefore P is equals to summation of I is equals to 1 to n, and it is considered as a Pi, and this is called as what? A additive law of probability, or we have to write, this is the expression for additive law of probability, that is P is equals to summation of I is equals to 1 to n and Pi. This is very important law we have to consider for the addition of the probability. After that, we have to consider the one more problem on that, that is right, the first problem we have, this is known as additive law of probability. Now consider the example. A card drawn from well shuffled pack of 52 card. Calculate the probability for this card to be either queen or king. Calculate the probability for this card to be either queen or king. This is the problem we have to consider here. See, first of all, we have to consider the law is what? P is equals to P1 plus P2 plus P3 plus dot 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 Pn. This is called as what? Additive law of probability. Similarly, we have to write that P is equals to summation of I is equals to 1 to n Pi. This is also known as what we have to say that additive law of probability. For this law, we have to consider the one problem, a card drawn from a well-shuffled pack of 52. We know the cat consists of a number of 52 number of cards, and in that we have to consider that is 13 cards of, say, we have to consider herd, then Scots, then what we have to say that each number of card consists of, say, let us, we have to consider the herd. Herd consists of the 13 number of cards, that is, say, Eka. Then what we have to consider is that 2, 3, 4, 5, 6, 7, 8, 9, 10. After that, we have to consider a queen, king. In that, we have to consider what is queen and king. Queen and king is considered here. And out of that 13 number of cards we have to consider, that is what we have to say that total 52 cards in the pack, and in that pack we have considered 4 kings. Each card consists of the 4 kings, and each card also consists of a card pack consists of 4 queens. And now we have to find the probability for that. First of all, we have to consider the total number of cards. Solution. Card in a pack is equals to total number of card is denoted by, say, n. N is equals to, say, 52. Total number of card n is equals to, we have to consider, say, 52. And but we are drawn a specific card, say, queen. Say queen. We are drawn a queen, but in the card consists of a 4 number of queens. That is, in Marathi we have to consider, say, Ispik, Badam, Chaukat, and what we have to consider that Pacific, like that. Ispik, Badam, herd, and flower. That are the 4 number of category of the card. Out of that, we have to say that 4 number of queens. One is for Ispik, one is for flower, another is for Badam, and then also we have to consider Chaukat. These out of 4 number of queens in the 52 number of cards, we have to find the probability of drawing a card of queen. What is the probability of drawing a card of a queen? So we have to consider here, there are 4 queens in a pack of cards. There are 4 number of queens in the pack of a cards. Therefore, the number of ways favorable to the first card is M1 is equals to, say, 4, and therefore probability P1 is equals to M1 upon N, and that is equals to 4 upon 52. This also written as what we have to say that 4 1 is 4, here 4 1 is 4, 1 is there, and 2, that is 12, 4 3 is 12. Yes, 1 by 12. That is, we have to consider, sorry, 12. This is what 4 1 is 4, this one is 1, here we have 2, 4 3 is 12. It gets this one, right? And after that, we have to find the similarly card probability for queen, similarly for king. There is number of kings in the pack of card is what we have. Again, we have to say that 4 number of kings in the pack of card. So we have to write that favorable cases are number of ways favorable, M2 is equals to what? 4. And then we have to get that P2 is equals to what? M2 upon N. That is again 4 upon 52. It gets that 1 upon 13. And then total probability we are going to find here. That is, therefore the probability of the card between either queen or king, probability of card either king or queen is P is equals to P1 plus P2, and that is equals to what we have. Again we have to write that this is what? 1 by 13 plus 1 by 13, and that is also equals to what we have to say that 2 by 1 by 13, that is LCM is also similar here, and we have to write that is equals to what? 2 by 13. 2 by 13. Or P is equals to 4 by P1 plus P2, that is equals to 4 by 52 plus 4 by 52, that is equals to 8 by 52. This is the way we have to find the probability of the either king or king. It is must be 2 by 13, or what we have to consider say 8 by 12. This is the probability we have to consider for the additive law of a probability. Write down this very important problem. It may be another type we have to say that either Gulla or king, either king Yakka or Gulla, what is the probability? Again we have to get the same answer, that is what? That is 2 by 13 or 8 by 15. Sometimes in the problem of multiple choice problem, we have to consider that sometimes option is 8 by 52. 8 by 52 is again we have to divide, it gets 2 by 13. This is the important condition for the probability of finding a either king or queen, or queen or king, or Ekka or king. There is also 4 number of Ekkas. There is also 4 number of Gullas. Also we have to consider 4 number of queens, and so answer is also we have to get the similar, that is a drawing a card, and out of that we have to what is the probability of either king or queen, right?